Very good morning. I'm really thankful to you for accepting the invitation from the side of Office of Doctoral Studies. JGU is a platform which always provide intense base for the conducting research to our research scholar. We are a dedicated university towards the research and the development. This is what we have separate office, that is Office of Doctoral Studies, which helps students in profiling, in managing, and in maintaining the research record and everything. And from the Office of Doctoral Studies, what we have started conducting seminars and webinars. So in the series of that webinar, Office of Doctoral Studies has invited you, Professor, and we are highly thankful to you on the behalf of Office of Doctoral Studies and OP Jindal Global University that you accepted the offer in spite of your busy schedule. I know that how much you're busy there in BHU, since you are involved in so many committees and examinations. So we are highly thankful to you, Professor, for sparing time and accepted the offer to enlighten my students that what is statistics and how it is being misused in different times. So when we talk about research, it is always quite evident. All the guests, I would like to give you a brief introduction about Professor Rai, and then we'll start the session. What did I discuss with Professor Rai? He told that first we are going to discuss the bit concept, use and misuse of statistics, and then it will be followed by question and answer session. So Professor Rai, I know Professor Rai since last 20 years, and it was a great learning. I learned a lot from Professor Rai. He's one of the prominent academician from the academia who have proved himself so many times. He was a gold medalist of statistics department and BHU in topper that time. He has a vast experience. He has that time way back he cleared NET, JRF, ISI, JRF, and so many other things. Dr. Rai, he has done his PhD in statistics. He has done his MPhil in statistics. He has done masters in statistics. And he is one of the named statistics you can find anywhere. Dr. Rai has a wide range of applications and research papers which he has published. He has published 40 plus research papers, 2 books, and several book chapters. And Dr. Rai had guided almost 5 to 6 PhD scholars and guided almost, I think, more than 10 master's dissertation theses. Dr. Rai is one of the dedicated professor who receives, I think, so many awards specifically for his teaching methodology, the way he convinced students. So he's one of the famous teacher even in BHU and other universities where he has delivered lecture. So we are highly thankful to you, Professor Rai, for sparing time and accepted our offer to talk on statistics. Now, when we talk about research, even when I started my journey, it was in my mind that research is a major part of research is being driven by analysis. But later on, I realized that analysis is just a single part of the entire process. There are a few more things is important. That is that I used to tell my student: what, why, and how. There are the 3 legs of research. What and why should be very strong. What should not be stand in isolation. Your what should always be supported by why, and how is the methodology. So methodology, you may adopt qualitative methodology, you may adopt quantitative methodology, but when he use quantitative methodology, majorly we use some statistical conceptualization, and sometimes we commit mistake. I still remember, I used to tell my students the story that one of my professor, when I was studying in my bachelor's degree, Professor Sharma, I still remember the story which he told that there was a village. The village was surrounded with flood, and the person who was aware about the statistic, he says, let me measure the height of my family members. And he measured the height of his family members, and he measured the depth of the flood level. And then what he find that on an average, the depth of flood level was comparatively less in comparison to the height of family member, and he decided that cross the flood. What happened at the last when he has reached out, what he find that he himself only and his wife was there, no one there beside that. And then he sat down on the bank of that river and started doing calculation where I has done mistake. He find everything is right, and then he asks this question to statistician that, oh, everything is right, average is, no, it's absolute, it's right. It's still why I lost my family. That was the major mega misuse of statistics. So statistics is like cheating, but if it is being misused, that then key will become poison. So we welcome Professor Rai. Professor Rai, I would like to hand over the session. I'm going to upload your presentation, which you have shared with me, and I'll run this parallelly. I make you presenter so that you can start presenting it. We have almost, Professor Rai, 1 hour, and within 1 hour, I'll request you to cover all the aspects of use and misuse of statistics, and then after that, we'll go for question and answer session. Professor Rai, I think you can see me. Can you see me?
Yeah, I can see you. I can see you.
Yeah. So I'm uploading this your presentation. Can you see your presentation now?
Yeah, it's coming.
So, Professor Rai, over to you.
Yeah, it's coming. Okay. Well,
yeah. So I'm handing over the session to you.
Well. Thank you very much, Dr. Pandey. You told a lot of things regarding me. You said a lot of things. Actually, I'm not like that, but you are saying because you are also too good. I always respect to work with you, and I always love with your company regarding academic and research, and I fortunate to work with you guys. Sometime the knowledge of statistics is a different thing, but the people to whom you are working is also very, very important. The collaboration is a very, very important thing. Then only you can understand the subject and its applicability all over the different stream. Well, a very good morning, folks, respected teachers and dear students. This is my privilege to be here to discuss the very, very important topic that mega misuse of statistics by, is just like if you misusing the statistics is just like stealing lightning in research by inexpert hand. So the 3 important key points of today's talk is, one is mega misuse, and mega misuse of statistics is another thing, and third one is the research and development in which such type of statistical tools are using and misusing. And the fourth very, very important thing is the people who are using this, whether they are expert or inexpert of data analysis and the knowledge of statistics. Well, I am not saying that only the people who are having good knowledge of statistics, who are having not good knowledge of statistics is only misusing. But here my submission is there are people who are having good knowledge of the subject, still they are misusing the subject. Because of the things, there are a number of things that is considerable during the application of statistics. Why I have used the word mega misuse, that is also very important. Misuse means just we are using the subject or the methodology in a wrong way. And mega misuse means the level of those errors or misusing is very high. The intensity is very high, irrespective of the subject in which you are using, in which it was applicable. Well, the one important thing also I must told you, because I must say you before starting my presentation, my discussion, that the subject statistics is used by different, in different area. Number of people are using, especially the people who are using, who are working in data analysis, they use statistics. And in research, in the R&D projects, in academic, master degree projects, everywhere people using. Because at end of the day, when you come up with the data, collection with data, at end of the day, you have to apply this statistical methodology, and then you have a good reproduction of papers, articles, or project reports, and then you will get a lot of things. But the problem is, even though we are aware of the subject, but we are not using it in a positive way. In a positive way means in a good way, where what are the assumptions, what are the different aspects of the subject or technology which is used is totally missing. Again, I must say one thing: data is everywhere. Data is everywhere. So people say if data is blowing in the air, so statistics is also blowing in the air. Okay, why I'm saying? Because you see, if you born and at end of the life, in between you face a lot of information, set of information, irrespective of the different stream. So what you do, if you tackle with those observations, then you have required the knowledge of subject, that you can say apart from your own subject in which you are using, the subject statistics is also important. Well, some people, so we should also know the definition of statistics. What statistics is, because today I'm going to talk about the misuse of statistics. So we should know what statistics is. So there are more than 100 definitions of statistics. Okay, but those definitions can be categorized in two different categories. The first one is in a singular sense and in a plural sense. Second one is in plural sense. In a plural sense, statistics is nothing, it is just like data. Statistics is just like a data, source of information, numerical statement of the facts. So as a plural sense, statistics is a numerical statement of the fact. Okay, I am still not coming on my slide. I'm just discussing. Recently, I'm coming on my slide. Okay. So as I told you, there are two different categories of definition of statistics. One is as a singular, another one is as a plural. As a singular, as a plural, I told statistics is a data, numerical statement of the fact. So where there is data, statistics is there. One more thing I want to say here: every numerical statement of the fact is not statistics. For example, say if I say the production of a company for one time period, is it a statistics? It is a data, that's fine, but is it a statistics? No. Statistics means at least we should have more than one information, so that those information can be comparable, can be compared together. Horace and Secretary definition is very, very important to understand here. Okay. Second important thing is statistics as a singular sense. As a singular sense, statistics is a subject. It gives methodology, tools, techniques, how to collect the information, how collect those raw data, how to represent those raw data, how to analyze those data, and how to interpret those data. So as a subject, statistics is a singular sense is considered, and as a plural, statistics is data. Now, I hope you understand the basic difference of definition of statistics, and there are more than 100 definitions. And I'm sure if you are a user of statistics, you should have your own definition, irrespective of the error and other things. Now, why I have said mega misuse of statistics is just like stealing lightning in research. You see, if you are using statistics, and if intensity of misusing the statistics is very high, it will be reflecting, irrespective of the subject. It will be reflecting if there are giant or people who know the statistics, if they see, then they will definitely find the error, just like a teacher. So be careful. Your article will not publish in a good journal or in a good research paper if it is a missing of those particular points in which you have made the analysis. Well, another thing is, before coming in deep, again, one thing I want to say, supporting the use of statistics, that we are tool provider. Statistics is a collection of tools, techniques. Problem is with you, with all other stream people, and we are as a tool provider, we will provide the techniques, how to tackle those data, those information, how to analyze our subject, those information using statistical tools. If you have problem, we have solution. We will provide good solution. Science without statistics has no roots, and statistics without science bear no fruits. This is also a very important quote regarding statistics. Well, now I just come to my slide. Next slide, Dr. Pandey, please. Well, you see here, why I have shown this, because as I told you, there are ample opportunity. You know, ample opportunity. We are the part of your, whole galaxy. Research is infinite. Questions are there in the nature, and answer and solutions are also there in the nature. We are required to find the question. And if you have a question, you see, in his initial starting point, you may not have the solution of that question. In a research problem, you see, you come with a problem and then make a literature review, you have some idea, and then on the basis of that idea, you proceed further. It may be possible that you will not get to the solution. But when you work out, you discuss, you read out, you consult the literature, and at the end of the day, you have solution. So ample information, ample opportunity, ample methodologies are there in the galaxy. But the important thing is we have to choose the best one. We have to find out the better one with discussion with the knowledgeable people or expert people. Because once you discuss with inexpert people, it might be possible that your problem will be solved, but at the end of the day, your result will be disastrous. Next slide, please. Well, so just coming in the, our presentation, our discussion, my question to you, so can statistics be manipulated? Because I say people are using statistics and they are actually misusing the statistics. I'm not saying that every people are misusing the statistics, but unwillingly or willingly it happened. So can statistics be manipulated? The answer is yeah, they sure can. They can be manipulated. Dr. Pandey understand better that we use a very strongest term that we call crime, statistical crime. If a person is using statistics in a wrong way, manipulating in a wrong way, they are crime. They are making crime. That we call a statistical crime. Well, there is no any punishment for that, but inherently it will destroy the planning. It will destroy the society. At the end of the day, it will destroy the nation if you are using the wrong statistical tool. Because sometimes the research projects are very, very, of a great amount. People extract something from that, and ultimately at the end of the day, suppose you, publish some report, and that report is not up to the, remarkable level, then it will destroy the planners. So do number lie? Now you are the judge of yourself. Next slide, please. Okay. So before coming the deep, I must tell you the very important statistical project that we have conducted, myself and my two colleagues, Professor Parikh and Professor Chandra, at Banasthali during 2011 to 2014. There we have conducted this research project, which was sponsored by University Grant Commission, and the title is a very, very interesting. The title is Evaluation of Misuse of Statistics in Rajasthan. I was surprised. I have not taken this project just by hook and crook. We have planned very, very, great effort we have made to get this project. Because so if some people are using anything, if you are doing research, and if I'm saying that you are doing wrong research, then it is not easy job. Okay. So anyhow, we got this project, and we implement this project in the whole Rajasthan. And what we did here, we collected information on research projects, R&D project, PhD research, and another data analysis work which are being done in different organizations, universities, institutions, government and non-government organizations. We have collected nearly 100 such projects which are based on data analysis, and then try to find out the errors. How difficult it was, you can understand, but we did it. And we have here, I'm showing this slide. You can find there are 5 different streams: education, management, sociology and psychology, home science, medical and agricultural science. From these 5 streams, we have collected different research project, different research, PhD research of the students, and some master degree project, and ultimately we got this particular set of information that I am summarizing in this next slide, that there are errors. There are 13 errors you can find. If you see on the slide, it started with representation error, inappropriate statistical tool, test of hypothesis error, description without significance and statistical tests are performed, p-value problem, degree of freedom problems, okay, writing interpretation, wrong interpretation of the results, and inappropriate decision in testing, avoid statistical assumptions, and up to test statistics is not used. There are 13, you see, there are 13 type of errors that we categorize in those projects. And you will be very, very, exciting. You will be excited to see that we got a lot of issues in those research projects, PhD thesis, and project immaterial of the departments of concern, whether it is in education department or management department, sociology or psychology department, home science department, medical and agriculture science department. Here we have computed is individual statistical error index by just using the concept of some index. Probably you heard human development index methodology. There are different indices people have developed. We have developed our own methodology to measure those errors. As a statistician, we sit together and discuss recurrent with a lot of good expertise people, and then we come up this methodology index, and then we see, if you see the representation error column row, you see whether it is the education department, management department, sociology or psychology, or home science department, the statistical error index is varying from 0.53 to 1. That means whatever the research project we have considered, the severity of error you can find out. Even though not only representation error, if you go through these all 13 different type of errors, you will see in this tabulation form we have shown the different severity of the error in those 100 research project, thesis, and R&D projects that we have considered to analyze the errors, misusing of the statistics. We call this as a misusing of statistics because willingly or unwillingly this thing happened. At end of the day, actually we have ranked also, but this is not so much important, because here we are not going to say that this particular stream is doing more error, this particular stream is doing less error. We have submitted a report to University Grant Commission with a very strong recommendation that a researcher working on data analysis, irrespective of the area, they must plan their methodology with the help of a statistician or the people who have expertise in the field of statistics. You see, why we have sent this? Because being the University Grant Commission or MHRD, they have power to send the guidelines to do the things. Though, as Pandey said that there are good universities, OP Jindal is one of that, and I know there are more than 100 universities all over the globe who are having Times Higher Education ranking or QS ranking. If you see the work articles or the presentation or the paper, you will find how they do the things. Means what are the level of consideration of the subject in nice way. So we can also do, well, I'm not saying that every people are doing that, but willingly or unwillingly it happened, because you see, statistical laws are not exact. So if we are using any statistical concept, techniques or tool, so we have to very careful, and every people are user of those techniques. So we should know where is the lacking and what are the lacking. If can we relax the assumption before going to the application of those methodology, we have to think of. And if we think in a nice way with a discussion, proper discussion, then life will be good. In my next slide, I am showing you the misleading graphs and statistics. See, my purpose is not only to point out the misuse. My purpose is to just point out the things and send a message to you guys that the people who are doing just research, they are at the beginning level of research, or the people who have done the research and just moving in another platform, if they are working, So they can use the concept in a nice way, in a proper way, with a proper discussion with the people before starting their research. Now they have to do that. You see this graphs. This graph is the number of graduates from community college for the year 1999 through 2003 in a given for a given institution. See, year is given 99 to 2003 and number of graduates enrollment is given. You see, there is no issue. See these two graphs, A and B. What is graph A? Graph A showing on axis X years, okay, and on axis Y the number of enrollment, graduate enrollments. Okay, if you see the graph, what is the trend? Till 99 to 2002, there is increment in the enrollment. But what happened in 2003? There is dropping. If you see the graph, the dropping is very high, looks very high. Okay, if you forget the y-axis, you see what happened. There is 210 to 160. So 50 students, near about 50, no, exactly 50 students are, their enrollment is less. So any management institute, organization, I'm not saying management institute, organization, they never want to show this A graph. If they want to publish in their reports or in their news magazines of the university, they will definitely not use this graph A. They will use graph B. Why? If you see graph B, see, if you squeeze the scaling, now in graph A, you see the scale was y-axis 130 to 210, 10 differences of the number of enrollment. And if you see in y-axis of graph B, the scaling is 100 to 250, 50 gaps. What do you find? Now 2002 to 2003, you see the slope of the graph. So can I say that this graph B is misleading? It is not giving the exact idea. Why I'm saying exact idea? Because here in graph A, every people can understand what is the difference. But suppose if I don't have this table above table, I have this graph. Can you tell me how much decrement is there from 2002 to 2003? So this is the mind game actually. Fellows, the problem is this. I'm not saying the graph B is wrong or graph A is good. But I'm saying that if you are showing this graph B, you are definitely misleading the things. When it will be correct? It would be better if you label the graph B. If you write the label of graph B, then it is better. Because if you label on the graph B, each point has number. Means 1999, even though in graph B, 1999, if you label, this point will show 140, this point will show 180, and the last point will show 160. Then it will be clear. There's no problem. Every people can understand in a better. Now, so next slide, please. Here I am just showing initially the misleading graphs. So if I am saying the misleading graphs, then definitely there is, unwillingly or willingly people are using wrong things. But okay, statistics allow those things. No, there's no problem, because I told you, even though you do statistical crime, there is no any punishment. Don't worry. Irrespective of it will destroy the system, that is different story. Oh, okay, in second graph you see, second graph, so the x-axis shows the year again, and y-axis shows the average house prices. This is the data of massive increase in the house prices in any particular year. You can find this graph on net easily. I have taken this up from net. Don't worry, I am not reproducing this graph. Okay, but I want to show it to you where the problem, where the issue actually. So you see, at first sight, I don't have data. You see this graph. Is there any problem in this graph? Yeah. If you ask to me, I have one problem, because we guys look only the problem. Okay. X-axis there is the year 1998 and 1999. In y-axis, what is there? 90 in y-axis 80,000, 81,000, 82,000. If you see the graph only, forget this y-axis. It looks that in 1999 the price is 3 times of 1998. Am I right or not? If you look this graph, guys, In 1999, the price looks 3 times of 1998. Now you say, no, no, sir, y-axis you see 80,000, 81,000, 82,000. My dear, you see the area of the histogram. It just looked 3 times. But data, so no, 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 there's only 1,000 increment. So it is a good graph. Next slide, please. Yeah, now say this. Do you find something else? The story is something else. If you change the scale from 10,000 to 90,000, you see what happened. In the previous graphs, it looks 3 times, but now it looks actual. That no, 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 there's not 3 times. There's only 1,000, 1,000, 1,000, 3,000 increment, my guys. So this is the way of moving, willingly or unwillingly, we are doing this. So this is misusing actually. Next slide, please. Yeah. This is a very, very interesting, graph in which I'm interested to discuss. See, I'm not going to say that people are doing wrong every time. Even though if I start to see my thesis, I will get a lot of issues in my thesis, in my research also. What I mean to convey, what my submission is to at least be honest what you are doing actually. And right, there's no problem to writing that I am relaxing the assumption and I am applying this graph or chart or this methodology. There's no issue. The smart people understand your problem and they accept also. But if you are cheating, if you are misusing, that is bad thing. You see this graph. This is graph of COVID-19, now a very, very disastrous pandemic all over the globe, all over the round. This is data I have taken from, source I have given, Worldmaster, Worldmeter, and the Statista site I have got from this. I'm not saying this is the wrong graph, but you see what this graph interpreted. Because I am not only to tell you the bad part, I am also here to tell the good part, okay? You see, this is a data from January 22 to June 14. Number of total cases of COVID-19 all over the ground. If you see the graph, it is nearly more than 7 millions. I say nearly 8 and 5 millions. Okay, 80 lakhs people all over the globe. More than that are affected by this coronavirus disease. Guys, what I want to tell you here. See, this trend is a linear. It looks linear. Am I right or not? Probably you agree that it looks linear. If you see January 22 to March 22, it's quite linear. It is just like a straight line. Okay. And once you see March 22 to June 14, it looks linear, but departed from linearity, it is just like a something curve type of thing. Some people say this is exponential. I'm not saying this is exponential. I'm saying, okay, but you see, if you see in the, at top, the graph showing, the graph tendency is linear. This is not linear actually, because you see, as a whole, you find it is a linear, and up to March, March 22 to June 14, it looks linear, but it is slightly curvial type of things. See, if the country where there is community spread, how can you say that the graph is linear? You can't say like that, because if I say, what WHO also say, the community spreading means what? Today it is 100, so next day it may be 500. After that it may be 10,000, 2,000. So where there is a community spread, it is not linear. If you but okay, so see, now people are how clever, they combine whole word graphs and make in a single frame of surface, and it looks like linear. So, well, at first time point, there is no problem. Graph is moving linearly, COVID is moving linearly, and we can plan on the basis of linearly. What happened? Now see what happened nowadays in Delhi. What happened? Not only Delhi, in India also you see what happened. If the number of tests increases, the number of cases also increases. Next slide, please. Dr. Pandey, next slide. Well, now I'm showing the graph. This was this particular was for the world. Now I'm trying to see the graph for Indian concern. Next slide. Now this is the beautiful graph. Okay. If you see this graph, you will be very happy, and we are also happy that in India life is good as compared to the world scenario. Nice. But you see there are three lines. One is red line is confirmed cases and another line is recovered, and the last one is death. The death is on parallel to x-axis. How beautiful it is, huh? Parallel to x-axis means very few numbers are death in our country as compared to the number of confirmed cases. You see, actually I have cut down the graph of the right hand side, but okay, you see there is a tendency to increase. All three are increasing irrespective of this death graph, because you see, because of the scaling problem, it looks on the x-axis overlapping with the x-axis. If you increase the x scale, it will go up to the x-axis. Okay, there is no problem. My issue was too, if you only see this curve, can you get any planning for future, for further? No. It is just for knowing us what is the thing going to happen in our country. But as for the planning, this graph cannot work. So is there any misusing? No, I'm not saying there is misusing. My concern is to only to see this graph, don't make any plan. And don't give your view or your idea. Why I'm saying like that? See, in our country, every day people using, government also using, there are good people in ICMR, and there are good group of analysts there in our country also. WHO is also doing a lot of things, and they are also they're also in trouble. You know, we can see a pandemic which is not in control, how can you do that? So you can do one thing, you know. There are three different aspects to compare. One is called, Dr. Pandey, please go in back slide. One, yeah. You see, you can give a very good picture if you measure the incidence rate, prevalence rate, and case fatality ratio. Might be you heard these three terms. You know, in a death analysis, in mortality analysis, people use these terms. So prevalence rate means the number of cases that are coming from past also. Today, how many deaths are there? Among those deaths, there are a number of people who are from the past days. So if disease moving forward, then you compute the prevalent. And incidence means only the number of cases that is tested, and among those tested cases, how many are there? So on the basis of that, denominator is the number of tests and numerator is the how many positive cases. Today, how much test and how much positive cases? This is incidence. Okay. And case fatality is the number of cases which are positive and how many deaths are there among those cases. And that should be in an interval point time, whether it is for a one day or whether it is for a duration, interval duration. Well, one more thing I want to say, as for the symptomatic and as for the asymptomatic. For symptomatic, we should know, we have to test it and find out how many asymptomatic cases are there. Among asymptomatic cases, how many are having positive sign of the corona, and compute the rate. Then similarly, from symptomatic case, you see how many symptomatic cases are tested and how many are having positive result. You compute another rate and club these two rates by some suitable weights. WHO say that in asymptomatic case, the probability of having corona is 0.3%, 0.2%. So take the weight accordingly and club these two rates, and quite, I hope this will give the better measure. I hope so. This is my submission. Maybe it requires a lot of discussion because government is facing a lot of issues. Next slide, please. Again, I am showing this graph, which is misleading statistics in science. You see, if you see these three graphs, this is a time series graph. Those guys who are doing research, irrespective of qualitative, if you are doing with quantitative data, definitely you understand there is a very good analysis we call time series analysis. And if there is a linear trend, regression is champion. But if trend is not linear, After doing a lot of transformation, if graph is not linear, it is a curvilinear, linear time series will not work. In that case, we use non-linear time series model. Garch model, Arch model, probably you guys heard about this. So there are good techniques. But okay, why I'm showing these three graphs here? If you see these three graphs, see, I'm talking about the scale issues that's showing on the graph, and that will give the misleading idea. And that is one type of misusing actually. Though it will solve the purpose of some people, but overall, if I say as an expert, I found that there is a problem. If you see the global air temperature changes from 1998 to 2012, see the first graph. Again, if we increase the time duration 1980 to 2012, we have second graph, and third graph is 1900 to 2012. See the global changes on the temperature. Then you will find, does in this time series analysis, linear line and line of regression will work out? No, it will not work out. But I am claiming you, I will found a number of paper who work with a linear time series modeling. So, okay, that will solve the purpose. That will give you research. You will awarded PhD. But my good friends, if you want to publish paper using this type of thing, then good paper, then it is very difficult. Next slide, please. Now, so I just started with showing some misuse of statistics. Not exactly misuse, I am saying that will unwillingly misuse. Sometime it is willingly. But our subject is very interesting. See, I told you, every people is, user of statistics. But once you discuss with expert guys, like we guys, me and myself and Dr. Pandey, we are two statisticians. He's applied statistician also nowadays. But we may not have same, thinking in a particular methodology using statistics. So I must say a quote: to every statistician, there is an opposite equivalent statistician. And if two statisticians agree, then it would be a conspiracy. So it is better that if two statisticians are two subject experts, are two analysts, opposes their methodology, opposes in the methodology. That's good, not bad. So how our subject statistics is important? See, a Frey guide, you know how it is important? It is the easiest subject actually. It is easy to communicate, easy to understand. The people make it fear. Okay, I can understand. If you tell me to go and study the bioinformatics, or study the management thing, or study the big graph of biology, I may feel a lot of problem. So in the same way, if I say you statistics is very easy, then you can find out no, it is not easy. Actually, I belong into this subject. That's why I'm saying it is easy. But my guys, it is easy. The way easy is, you required only to understand what you actually going to apply. I'm not saying go to study each and every concept of statistics. My only submission is, I only requesting you that whatever the method or technology or mechanism, techniques you use in statistics, at least get the deep knowledge of those techniques. If you are a management people, you have a so if you are using principal component analysis, so at least you should know what is PCA. If you take the number of variable and absolute value, you can't use PCA. You have to standardize those values, because ultimately PCA added those variable and generate another transformed variable. So if X, Y, Z, these all are having different units, you can't add those three different units. So at least we should know what is the standardization. So, okay. So if you see a Frey diagram defined by people from different discipline, what mathematicians say? Mathematicians always say it is a round object transformed into a flat one. What physicists say? An egg fried, that's all. Physicists never bother about that. They only bother about the physical condition of the subject. Chemists, they see, well, whether this is change of one state to another state. Doctors say, no, now it is free from human foodborne disease. Biologists say it is unhatchable, not comparable. But what you see, if you study, if you see the logic of mathematician to biologist, sometimes it requires a lot of difficulty to understand what actually they want to say. But if you see the statistician point of view, what it is, a fried egg is an object with a round shape if mom makes it, and a variable shape, round on an average if dad makes it. How easily communicated this subject. So the important thing is, this is actually epigram of statistics I have taken from the C.R. Rao book. I am fortunate to meet with Professor C.R. Rao a couple of times, and he discussed a lot of things regarding those things. Next slide, please. So, so the problem is, how can you discover the misuse of statistics? Actually, people say that because of this misusing, people have distrust about the subject statistics, and they quote that there are 3 types of lie. One is lie, white lie, and statistics. White lie, damn lie, and statistics. But actually, the situation is not like that. We, the people who are user of statistics, make it not good for the people who are actually user of that. They have something doubt in their mind. Actually, see, I am here showing this slide. This is quite prevalent here to show you guys, because this I have taken from R.K. Lakshman, the Times of India. Even though this slide I have taken with the discussion from T.C.A. Anand, the former Chief Statistician of India. During his deliberation, he showed this slide, and he showed this slide in terms of economic behavior. I am saying this is quite relevant for the statistical behavior also. Why I am saying? You see the article, you see the Lakshman, R.K. Lakshman, this picture. What he say? Of course, I have a car, but I don't have a road to drive it on. Why he's showing like that? The problem is, today there are 1,000 places from where you can get the knowledge of statistics. There are 1,000 places, there are 1,000 websites where you can get the idea about the subject. 1,000 softwares are there. But as Dr. Pandey started to say, we should know what to apply, why to apply, where to apply, then how to apply. He said, you have to know. I have plenty of, suppose I have t-test also in my hand. I have non-parametric test, man-meeting U test also in my hand. But actually we have to think which one is apply. Like R.K. Lakshman picture, I have car, but I don't have road. The problem is, we have method, we have subject, we have tools, but where to apply, which tool, we are missing in that. And that's why the misuse of the statistics is coming into the picture. Before applying those methods, we should know these all points: physical infrastructure of capital. This is basically for the economic perspective. But as for the statistics perspective, this is also true. Whether the subject idea is qualitative, whether it is quality based, that means whatever the technique I am using, what is the use of that technique, whether it is relevant for that or not. Maintenance. If I found some outlier, can this method will good for that? I will show in my next slide the concept of outlier. If I am confident that no, even though in outlier cases I can use that, it's not possible. If you see in assessing the indicator in the next slide, also you see, this is also very interesting slide. You see, robustness is very important in statistical terminology. I told you again that statistical laws are not exact. Okay? Every people are using statistical laws. And if statistical law is not exact, their result is going to deviate. I am saying robustness is very important. Don't deviate. Whatever the result you are getting, just try to defend those results. If it is not beyond, if it is beyond, then you see your whole procedure, because robustness is very important. Resistant to the error, whatever the model, test, or procedure you are using, it should be robust. The statistical concepts say, if your model is robust, your test procedure is robust, then your life is easy. Your research is very, very renowned. Every people will appreciate it. Don't worry. And another thing is linkage to the policy. Whatever the method you are using, whatever the research you are doing, is there any linkages with the policy mechanism? You have to think of. कोई research कर लिया, अच्छा paper publish हो गया, that is not of our objective only, guys. That's why we are misleading. See, the people are getting Nobel Prize to using very, very small thing of statistics. You know, controlled randomized trial, CRT. We all know the clinical trial practices because that is of our subject. But we never think of to using those things in poverty measurement. But the guy, Bhattacharya, Banerjee, those guys, you know, they are using those method because they are trying to using the basic fundamental method to linkage with the policy, and they got the Nobel Prize. So guys, you all have idea, you all have caliber to get it. But the only problem is whatever the subject we are using, at least we use in a proper way and in a proper practice. Next slide, please. Next slide, Dr. Pandey. Yeah, this is a very, very important point of misusing the statistics. You see what happened in your data. Before reading this particular slide, I want to tell you the two important examples. The first example is based on the correlation. See, if I collected a data, suppose my students come and ask, sir, I want to see the behavior of crime in Varanasi city. Okay, I said him, okay, go and collect the information that how many police stations are there, how many police personnel are there, and also note down how many crimes are there committed during that particular time period in the city. So they come with the data at the end of the month. One is, I said, just take one variable X, that is the number of police personnel increases during the city from last 1 year, and Y, the number of crimes reported in the city. You know what happened? X is one variable, suppose, number of police personnel, and Y is another variable, that number of cases reported in the city. And the student said, sir, why not make a correlation? I said, okay, compute what is the correlation. I got correlation 0.89, 89% correlation. Now, guys, how interpret this? That means my students say, sir, there are 90% chance that if number of police personnel increases, the crime in city will also increase. Is it the interpretation? Is it the interpretation that as the number of police personnel increases, the crime rate will also increase in the city? Reporting will also increase? Okay, another thing is, suppose you collect information of rainfall in America of last 2 years and the production of food grain in India. Say one is X, another is Y, and again compute the correlation and regression. We will have result. You will find there is some correlation, but such correlation are nonsense correlation. You have to know, you have to understand whether which variable X I have to take, which variable Y I have to take, whether there is a relation, actual relation between X and Y or not. केवल दो कोई भी इंडिपेंडेंट वेरिएबल डालोगे ना एसपीएसएस में, स्टैटिस्टिका में और आर में, तो कोरिलेशन निकल के आ जाएगा, रिग्रेशन भी निकल के आ जाएगा. बट प्रॉब्लम इज we have to find out which one is the input variable, which one is output variable. If garbage in, garbage out, be careful. So we have to take care of. So only interpretation and analysis is important, which destroy the system. Okay, this is also very important thing because we know we do research. So at the beginning, our supervisor also used to say, every people suffer from this. We as supervisor also used to say, no, ratio estimator is better estimator. अगर ये अच्छा नहीं आया तो तुम्हारा रिसर्च गलत है. So what I say in conclusion, ये दो फिगर बनाया इसने, बॉस ने, और अपने क्लाइंट को कह रहा है कि हम कुछ ऐसा स्टैटिस्टिक्स लगाओ जिससे ये प्रूफ हो जाए. देखिए भाई, ये भी नहीं चाहिए. This is not a good way. If you do like that, life will be disastrous. This is another way to misuse the statistics. Don't be like that. Okay, there is some prior information, there is some subjective belief, but don't be rigid with those belief and subjective prior information. If my prior information will give something else, so I can have to change my belief. There is some objectivity in the system. Why not use those objective definition and objective methodology? Change it. Well, now I come to some quick summarization of what I have discussed in my previous slides, that statistics can be misleading. Misuse of statistics is accidental or purposeful, as I told you, willingly or unwillingly it can be happen. But it is happened beyond of these 6 different categories because of these 6 different branches. You know, if you control on these 6 different, then probably there is less probability to commit an error. Still there is some error because our subject always talk about the error. You know, we always measure about the error, but try to minimize those error, though those output errors. So these are the 6 points: faulty polling, flawed correlations, data fishing. You all know these things because you will find this on the net also. Any teacher can tell you these things. Why I want to show it? Because this is the platform, as Dr. Pandey said, that there are numerous students who actually want to do research. Good research they want to do. But the problem is they are hopeless because there are plenty places where there are plenty methods are given. They are confused. And at the end of the day, they have to submit their PhD thesis or their project or their report. So they are forced to choose any method, whether it is good or not. So next slide. Yeah, this is automatically clear. I told you the one important and very important point here is sample size determination, which is important because sample size determination will create a lot of thing in data analysis, in research analysis, because you see, sample is the only option through which you can move to give the estimate of population. So if my sample, nowadays it happened with the COVID case, you see, initially in other developed countries, there were nearly 1 lakh sample tests, more than 70,000 sample tests in 1 million population for the COVID test. So their proportion of affected people were high, but in India, you see, initially there were very less amount of the sample test, and those sample tests still are not actual sample because we have no any methodology to take a random sampling. So we were missing on that. So if we are not doing the random testing, and if the sample size determination is not clear, so we will not give the ideal picture. Well, there are a number of issues, but we have to think of. So what actually this purpose solve? Now I want to tell you a little bit about the inferential part, and if time will permit, then I will say 4 to 5 minutes on modeling. Okay, Dr. Pandey? Is there any problem? 5-10 minutes I can take more?
Yes, Professor, we are planning to, if you can compile it till 12:15, then we'll have 15-20 minute quick Q&A session.
Sure. I will finish it within the 10 to 15 minutes.
Sure. Thank you, Professor.
Okay. So the concept, statistical inference. You see, there are 2 different ways to, actually I am here not only to tell the negative part of the statistics, the positive part is also important. And though I am just want to point out that where we are lacking, but actually our subject mean to say a lot of things. One is descriptive analysis, another is inferential analysis. The people who do research, they understand this. Now there is a lot of charm from inferential analysis, means for unknown parameter means some characteristics, some qualitative characteristics or quantitative characteristics, which is unknown in nature. And we want to tell about those characteristics. We want to estimate about those characteristics. We want to predict about those characteristics on the basis of the sample information. So this is the very important part of statistics, that on the basis of sample information, estimate, predict for the population characteristics with calculated degree of certainty. That is very important. There's calculated degree of certainty. That means there is a possibility of error itself in analysis. So you all know this. Biostatistics people do this. There is a population parameter. We guys also do. We have population parameter. Those parameters may be statistically quantified as mean, median, mode, numerical measurements, quantiles, ratios, rates, and those are actually unknown quantity, those but constant. And on the basis of sample information, we make it using the statistics. If you have sample information, use statistics, and whatever the information embedded in that statistics, extract those information to give the estimate of population parameter. Next slide. So use a statistical approach to make an inference about the distribution of a sample of data we collect. Actually, once we talk about this sampling distribution, data, probability, the student from other stream may have problem, because these things always gives a very bad picture, because we always scared with mathematics. The other people who are user of statistics, they don't have mathematical background, they are scaring actually. But don't scare. Nowadays, there are plenty of software, but the only thing is the software you are using, the method you are using, you concern with the expert person, and then that will be okay. There's no problem. The interpretation analysis will be understandable if you contact with the good people of the subject. Okay. So first of all, what you do, what distribution from which the data has been collected. There are plenty of discrete and continuous distribution. And now more than 90% of the statistical concept and mechanism are based on the assumption that the data from which it is coming is normally distributed. Just go upside. Yeah, just wait here. Just wait. Just next slide. Next slide. Next slide. Next slide, Dr. Pandey. Yeah, just wait. So you look this particular. If I at end of the day, anyhow, I come up with the knowledge that my data coming from some distribution, then life is okay. But suppose if I don't have idea that from which distribution my data is coming, see the case. Data on monthly income of 5 different families. You see, there are 5 different families whose monthly income has been calculated, $30,000 to and 30,000, 35,000, 25,000, 30,000. If you compute the just simple measure of central tendency, mean and median, luckily we got this, both are equal for this 5 income family members. See the case 2. If one data is $1,30,000 and the other one is 30,000, 35,000, 25,000, 30,000, and if you compute the basic measure of central tendency, mean and median, you see mean is now 50,000. Now, what is the problem? Student has only option to take 5 data. Suppose not possible to take more data. Just generalize this to the population. Okay, the data may be more than that. I have just taken this example to show you how it is severe to understand with the outlier. Even though if you don't have idea about from which distribution the data is coming. You see, in the second case, mean median are not same. So if my supervisor say, your supervisor say, your guide say that यार ये तो तुमने गलत कर दिया, ऊपर वाला तुम्हारा जो मेरा जो स्टूडेंट था उसने तो कहा था कि मीन मीडियन बराबर होता है, तुम्हारे केस में जो है ये तो बड़ा गड़बड़ आ रहा है, तो you can't use this method. मीन मत निकालो, मीन निकालना ही नहीं चाहिए. What is the problem actually with data? The problem is the outlier. There are 5 observations, so we can get easily that which one is the outlier. Outlier is, very important points in any analysis, because actually if there are more outliers, your whole analysis will go on. If you are avoiding those outliers, then the thing will be very complicated. But I'm also not saying that every time outliers are dangerous. Outliers can be obtained on the basis of, leverage point and inferential point. In regression analysis, we have 2 important points. One we call leverage point, another we call inferential point. Even that there is outlier, but outlier is on the same line. It is not going to change the, tangent values, beta values. Then there's no problem. You can go ahead, take the outlier. There's no problem. But if it changes the behavior of one line, then this is the influential point. We can't exclude those outliers. Here my outlier is influential. So 5 observation है तो बड़ा easily measure हो रहा है. But if there are 1,000 observations, how can you easily get the outlier? So for that, in statistics, there is number of analysis, residual analysis. The people who know the regression modeling, they know they can use. But my submission is here only to see if you have such type of data, such type of observations, such type of things. So before applying the methodology, initial methodology, कि नहीं साहब हमें mean and median ही नहीं निकालना है, we have to go beyond and come up with the better solution. Next slide, please. Yeah, ultimately at the end of the day, you all know the nature of the data will be either negative skewed, positive skewed, and no skewed. No skewed is a very, very important. But life is not easy. You will never get no skewed. Definitely it is either positive or negative. If it is quite close to symmetrical, we make the assumption, then we have parametric test. But if my data is skewed data, my guys, don't use the parametric test. There is non-parametric test available in the statistics, and you can consult with the teacher, supervisor, even you can understand, you can discuss, you can find a lot of platform where those methods are given. Next slide, please. Next slide. Okay, so this is just a symmetrical way of showing the data, but I told you that life is not like that. Every time you never get such type of thing. This is the last point of my topic. What is the model? Actually, it is impossible to show all 30 slides, but just I want to discuss a little bit, and then I want to stop my discussion so that we can make some question answer. That every time we search to get a model, okay, what is the model actually? You know, in our research also we use this model term inherently every time, but we actually know what model is. Yeah, I'm not saying that people are not knowing. It's a very easiest way to get the model, but in our statistical methodological term, the model is the mathematical formulation, functional formulation of the random phenomena. That's important. You want to get a mathematical form of the random phenomena. If I have one variable that we call x, another variable that we call y, this yx is also very critical to understand. Which one is x, which one is y? If you change the subject string, that x will be different. The way of calling that x is different. Sometimes x is called independent variable. Sometimes x is called explanatory variable. Sometimes x is called input variable. Sometimes x is called control variable. Sometimes x is called control variable. That's fine. Endogenous variable. So in that sense, what is the y variable? Sometimes it is called dependent variable. Sometimes it is called explained variable. Sometimes it is called regressed variable. Sometimes it is called response variable. And if you search to other literature, you will have different name of x and y. So don't bother the name of x and y. Only bother with the characteristics of x and y. Okay, x is the input variable. Whether it may be qualitative, may be quantitative, no problem. But y is always quantitative variable if I'm talking about the multiple regression. But if I'm talking about the logistic regression, logic probability model, that y is qualitative in nature. Okay. Sometimes y may have only two variables in qualitative sense, 0 and 1, and sometimes y may have more than two values, 0, 1, and 2. If more than one value of y is there, then we use multivariate regression model, whether it is logistic regression or whether it is multiple regression. So be careful. So actually we have two different models, deterministic model, probabilistic model. Deterministic model means what? The things are well known in its advance. That means all mathematical models are deterministic. That means if I say all curves, mathematical curves, straight line curve, straight line, or parabolic curve, or third degree polynomial, or exponential, or logistic, these all are the deterministic. And meanwhile, the probabilistic model means we all have distributions where randomness involved, where probability theory is involved. I hope, Dr. Pandey, we have to stop because there are 25 more slides, and it is difficult to explain all those slides. But I hope whatever the message I want to deliver, I have delivered. That means actually we have to go for the understanding the best practices of the subject, and then only apply those methodology by concerning with the people of the subject, expert of the subject, and the other things. You can share these all to the students, no problem, and they can discuss, and you can give my mail ID to those guys also. Not only at this platform, they can also discuss with other platform on mail if we are not able to, because I hope there are a number of queries among the students, and each query it is not possible to sort out in this short duration of time. But I am always ready for those guys whosoever have any doubt, and if I am able to finish those doubts, then I'll be very happy.
Thank you, Professor. Thank you very much for your insightful discussion and talk. Yes, indeed, it is important to understand that what is the role of statistics, where we should use and what we should use and what not to use. Because it has on words, if we'll use, like, sometime what we require a needle. And if on the, like, if needle is required and we are using short, then it is not being suggested, that not being, fulfilling all the criteria. So thank you for highlighting the key insights here of misuse of statistics. Yes, there are a few questions. I'm sure that participants are quite eager to ask few questions. So I would like to open this platform now. If there are some questions, anybody would like to ask any question, no, we welcome the Q&A session. So I request you all, if you would like to ask any question, please ask question to Professor Rai. The floor is open to all of you. Any question? Anyone? So I think still people are thinking that what to ask and what to not ask. Professor
Okay.
Rai, yeah, Professor Rai, there. Yeah. So Takpan Nairji, Preeti, she's, I think, from Dubai. Yeah, Preeti. Hi, Preeti. How are you? Long time. I think we met way back. Thank you, Preeti. So Preeti, she's first of all giving you thanks, Professor, for your insightful and in-depth session. Oh, so she is in ARU Cambridge now, Preeti. So Preeti is writing, is there a minimum good sample size for running structural equation modeling?
Yeah, it depends on the size of your nodes, means the population size for which you are taking care of. There are different ways to compute the sample size, but it is also depends on different aspect. What is the heterogeneity of the parameters in which you are interested so far for the population which you are taking care of? Means how much heterogeneity, means the standard deviation of your nodes. There must be some measurements. If there's no measurements, at least you have made some scaling. So how much scatteredness is there in the scaling? On the basis of that, and how many allowable errors there are taken care of, on the basis of that you decide. Even though there's, if you understood the inferential aspect, there is a level of significance on which level of significance you are talking about. So see, there are three different things: level of significance, allowable error, and heterogeneity of the population for which you are taking care of, for structural analysis or any other aspect. So there is no any such way that this with the minimum size, sample size you can go far. But as I told you now, whatever I am telling the figure, that may be solve the purpose, but that is not exactly way to get the sample size. Okay, so for that you have
she's adding that if it's a global study.
Okay.
Yeah.
Global study.
Yeah, what she's telling that if it's a global, if she would like to adopt a structural equation model for a study which is a global centric study, what should be the whether size matter? If size matter, what the size should be?
No, actually, see, be careful. If you are working with a global study, size is a totally relative aspect. I am not able to tell exactly one figure for the size at this level before understanding your whole phenomena, whole process. But I am telling you, there is historical way also to compare what actually people are taking care for this structural modeling, how much sample size they are taking care of, and what are the methodology they are taking care of. Because you see, literature is also important to understand. If you are taking with a particular aspect, I can tell you what is the size, but the important thing is whatever the other people they are using those particular in that particular population parameters. So I will be happy to answer the question if you share your all other issue problem on my mail, so that I can see and I can tell you what actually size should be.
Professor Rai, with your permission, if you allow, I can add something in answering this
Yeah, sure.
one.
Every time I know I love to
Yeah.
discuss and take your opinion.
Priti, what happened, General, in management book, if you go here and all and others, what they call even for running your CFA, that is confirmatory factor analysis before we run EFA. So the responses, number of responses per variable minimum, it is being said 5 to 8 times. But in literature, I have seen people use response on each variable around 10. It means you have a single variable, then minimum 10 response, 10 to 20 response. So if you take, let's suppose you have 25 variable, so 25 into 10, that is 250 should be your minimum sample size. But if you can take 500, then definitely it is a sufficient sample size for running EFA. Further CFA also, but for after CFA, what happened? If you are using AMOS for running structural equation modeling, then sample size matter. But now in these days, I was reading a literature which is Smart PLS. So Smart PLS is a software available. The sample size restriction there in AMOS, if you use Smart PLS, is not affecting a result a lot. I don't know why, but it is written somewhere, and I have run it on Smart PLS, and same thing I have run on AMOS. I find the huge differences are there. And then I was reading that what might be differences, and then I read and I found that Smart PLS is more cubed in terms of sample. I don't know whether I'm correct or not, but whatever I have read, I'm just telling you right now.
Yeah, one more thing I want to add, Dr. Pandey, what Preeti is saying, you see, as you told also, if you increase the variable, your data matrix will be automatically increased. Okay, if I have 5 variable or 10 variables corresponding, how much subject item I should need? So minimum 100 you will find everywhere. Okay, even though in literature for doing this PCA, this analysis, 100 minimum they have considered, but it depends how much variable they are taking care of. But also you see, if you increase the number of variables, then the faulty correlation will take into picture, and those faulty correlation will destroy a lot of things. So this is also important.
We have to account even when we are increasing the number of variable, we have to check it out that whether these variable which has been included in the study are significant or not. So first of all, you have to check it out whether this variable which you are including in the study are significant or not. And if you found those variable are significant, then include those variables into the model, and then decide that what should be sample size. Thumb rule, according to Hare and all, they have given a table even. If you read it out, they have given a table which is ranging from 5 to 200, 5 to 20 per ratio. You are using Stata software. I'm not using Stata. Professor, she's asking, what about Stata software? If she's using, have you used Stata software for running?
Yeah, that is good. Stata software is very better for this one. But other than Stata software, also you can use. And why not you work with R? R is a very good one.
Yeah.
And if you have idea of Python, it is far better than R. Stata will have, in Stata you have to write syntax in something different way. But even though in R, if you have some issue regarding writing of any syntax or programming, there are number of concepts and knowledge. If you are missing, you'll directly get from Google. Even though there is number of people through whom you can contact, and you can better use R.
Because this is what I personally feel. Preeti, I personally feel I use R, and I find it's more interactive and more easy. Nisha is asking, R is the best for statistical analysis. Python is great in the data science and data engineering. Professor Rai, one of our guests, is the director eduxguru.com. Ravi Krishna Pandey is asking one question to you. He's asking, sir, please give a gist about the data cleaning methodology.
Yeah. So, okay. Thank you, Ravi, for asking this. Data cleaning, you see, data cleaning, all those methods which are using in data mining, which are using in big data analytics is there. Probably you heard about STAR method. I don't know whether have you seen or not. Statistical, auto-regressive methods people are using to cleaning the data. Basically, you see, you are. I hope you understand the Python well and R well. I can send you the different literature on data mining practices. But again, issue will be the same as Dr. Pandey said that. In data mining situation, still where data matrix is very high, means data, data all depend on the data matrix. If you increase the rows and columns, at end of the day, whatever the beta coefficient you estimates, that will create a lot of problems. So, because that parameter estimates depends on the variable which you are taking care of in your data matrix. So, two things are very important. First, whatever the variable selection methods you have to adopt. Another is which model you are using in the data mining. So one is variable selection problem. Another is the model selection problem. Once you are final conclusion to get it the variable selection problem, suppose 7 to 8 variables in there in my picture. Now use the model. Which model I am taking care of? If I am using polynomial regression model, then in data cleaning, there is no issue. But if I am using simple multiple regression, then problem. So RSA analysis is very important in this data mining issues, and you have to take care of that. And for that, you require the softwares. And I know that you know better software skills.
Thank you, Professor. With your permission, if you allow, I would like to add a few more things here.
Sure.
So Ravi, data cleaning is I think one of the basic plan which you should go before doing any sort of analysis. Data cleaning is required, but again, what sort of data cleaning you're talking about? What type of variation you are having inside your data? When you collect the data, there might be a response bias. If you are using, let's suppose, some questionnaire-based information, and what you're using, respondents are giving their views on a platform which is a questionnaire form. What you should see, first of all, that whether if you're having some time frame, let's suppose you have 20 questions and you decided that this 20 questions can be answered in a time limit of 10 to 15 minutes. Let's suppose somebody has answered all the questions in less than 1 minute. What it sounds. Let's suppose somebody has written 1 everywhere. What it sounds. So you have to check it out that what is the consistency in the responses. If you find, I'll suggest a simple thing, just calculate variance. Just do nothing, just calculate the variance of all the responses like question wise. If you find that variance is 0, what it means? It means the person has not thought anything, he has just clicked 1 everywhere, and that response is actually useless. You're not going to get anything from there. So you expect.
So one thing, one thing that I want to add, Pandey, you are correct. In data cleaning process, 3 important methodology we go for. One is the Bayesian modeling. In Bayesian modeling, as you are saying, what happened? Suppose I have some subjective belief, prior belief that the person will going to give answer only 1, or they are excluding those, they are not participating in that particular option. So you will get 0, 0, 0, 0, 0 for that. So if among data for one particular variable, I get 80% times 0, so it would be better to clean it out. But it depends on what type of prior degree of belief I have. Sometimes if say, no, I have no any problem if I take a uniform prior for that, whatever the people are writing, whether 0 or 1, I take that its weight is proportional to 1. So Bayesian modeling is one important aspect here in data cleaning process people are using. That is also an important practice.
Ravi, I would like to tell you a few more things. So one is important point which I told you, you should check whether the consistency in responses. You can check it out with the help of variability. You can just simple do the statistics, run the frequency, and you can check it out on the variable list that what is a scenario. You can find it out. The second point, which is very important when you are going for the data cleaning, you're missing data. You should check it out that what is the percentage of missing data. If you're using SPSS or R, then you can even check it out that if I'm running the analysis with the help of included this missing data, what is the information? And if I'm imputing it or replacing this missing one, and then I'm running the analysis, and you can even use hypothesis testing that before and after, like when missing data was available in the entire data set, when missing data is being separated, whether the decision is significant or not. You can check it out whether the missing information has significantly impacted your entire result or not. So you should be aware with the missing data. You should be aware with this type of responses. You should be aware by outliers. Outliers may destroy your entire model. Now, outliers can influence your result by pulling the mean away from the median. And the two types of outlier exist generally. What happened? Individual variable and outliers for the model. So you have to check it out that which type of outlier your model does it has. It may be an individual basis and it may be model-based outlier that needs to be detect and provide the solution. Third point is detecting multivariate influences outlier. When we say multivariate influences outlier, it means what? I think when we go for like there is the cases has been used Cook's distance test. So that has been used even to conservative. That is a conservative approach. But I would like to recommend you to examine this influential cases specifically for multivariate influential outlier. Use Cook's distance formula that will help you to understand more about multivariate influential outlier. If you're dealing along with the regression, then definitely detecting normalcy. You can go by shape and skewness and a kurtosis of the curve that needs to be checked it out. Whether it's a single model, bimodal, what is the transformation, whether it has some sort of linearity or not, because it's assumptions. So you have to check all these. If you're running a regression model, check whether homoscedasticity plot is there. No, it should be multi-quantity check. You should check it out. The VIF value in SPSS, you can check it out. The VIF value should be less than 3. If it is less than 3, then not a problem. If it is more than 3, then you can say it's a potential problem. If it is more than 5, then it's a very likely problem. If it is more than 10, then it's definitely a problem. You can use VIF value. These are the things you can see before going the final analysis doing analysis. You should check at least your data cleaning in these points.
So yeah, I completely I completely agree with your point. Basically, I think he should not be very confused. The two important things are there. One is whether outliers are there or not. For that, just use the outlier measurement practices. Residual analysis is there. Simply use leverage points and influential point by D-beta statistics. This is very simple. Any software from that you can do that. And another second important aspect is, just as you are saying, that variability among the responses. Some students are saying imputation method is also very important for that. Imputation only use if you really think that these missing information in my structural in my data mining work out. My regression modeling is going to affect it if I don't have idea about those variable. So two important things. One, which variable I have to be taken care of, outlier is there or not. So on the using of some good statistics, D-beta statistics and residual methods, you can first find out those outliers, then clean it out. Second, on the basis of frequentist analysis, as Dr. Pandey is saying, you see what heterogeneity are there among the responses, and on the basis of that, you can get it, you clear your data, clean your data. And it is also important which model at the end of the day you are going to use, because according to using of the model, you have to again come with your data. So model assumptions where data meet or not, this is also important. Yeah, Dr. Pandey.
Yeah, so Gaurav Bahuguna from Sapient. Now I think Gaurav changed recently. He joined Standard Charter probably. So Gaurav is thanking you, Professor, for a nice talk. He says that I'm lucky to attend your classes somewhere sometime. So he's thanking you. He's from industry. is a practitioner, industry practitioner who is working in industry and using statistics at various platform. Meanwhile, one of our professor from Dehradun, and he has also done PhD from BHU. He is thanking you. His name is Dr. Prayas Sharma. He is thanking you for insightful session and is asking that, is telling that imputation technique is there to deal with the missing data. We can use if it is required. So yes,
I agree, Dr. Prayas. Thank you very much that you heard my lecture. Actually, imputation method have their own limitation also. Because sometimes you see, if you work with the change point analysis, okay? So for change point analysis, if you go for the imputation method, then the error will be, the statistical error in terms of MSE of those estimator which you are using, that will disastrous sometime. The MSE value is very high, because whatever the imputation method you have used, it might be possible that that is not valid in that particular phenomena. Though I agree that there are numerous methods you can go for, but first of all, why not use numerical analysis technique, simple basic numerical analysis testing before going to the imputation? Well, imputation is another thing. And if these both don't work, then I am most welcome to domain estimation problem, small area estimation problem. Even though we don't have information about the observation, we never impute that. Without that observation, we have method to estimate using design model approach. Okay, so for that we have to discuss on something different platform, but there are methodology. I agree with Priyas. Imputation is one important method that can be used to estimate the missing data.
Dr. Sarni Jain is giving you thanks. He's telling us that thank you for an insightful session, and is thanking even ODS Office of Doctoral Studies for organizing this session. And she's telling that really it's very important to have more accurate information of statistics, where to use better than where not to use. That is most important point. So Sarni, thank you for attending the session. One of another professor, Professor Rajeshwari Idre, again from Dehradun, she is even writing that one of the best sessions which she has attended, and she's thanking the Office of Doctoral Studies and JGU and Piyush, Dr. Piyush too, so for enlightening and giving an insightful session.
Thank you very much for attending my session.
Professor Piyush, yeah. So I would like to ask one simple question.
Yeah. Your questions are Your questions are simple but very tricky. Your questions are very simple but very tricky. Yeah.
I'm not going to ask any tricky questions. There are some doubts which I was thinking. So when we talk about statistical applications or uses, while variable selection stays, so sometimes what happens, we do have our variables in our hand, and we can choose. Sometimes we have that liberty to choose the variables, and sometimes we don't have that liberty to choose those variables. We are bounded to choose that variable, and still we know that these variables doesn't contain meaningful information, but we do not have any other option. What you suggest in that situation, what we should do? Whether we should estimate, whether we should use simulation to generate the data and ignore that variable, or take the same variable and try to clean it. What is your suggestion at that point?
Actually, Dr. Pandey, your question will be answered in two different ways. The first important thing is might be about misspecification problem. It's a very, very important problem in econometrics theory. In regression analysis, also people use misspecification of the model. If my variable selection is not good, my model will be misspecified. Actually, the issue is what happened at end of the day, my aim is to get an estimator which have less bias and less variance, less MSE. Okay. So one group of people only interested in the bias reduction. Another group of people interested not only bias reduction but MSE, mean square error reduction, or you can say SRSC reduction, or you can say increment of PRE values. See, if my model is misspecified by the virtue of wrong variable selection, then my VIF value will going to damage. Sometime it happened that if VIF value is very high, or suppose if variance will be 0, 1 by 0 will be infinity, my model gone. Even though it's a very simple variable, it's a single variable, but it is a very important to include in the model. So everything depends on the model. You are saying that variable selection in one aspect, but model selection move parallelly. My variable selection ultimately influenced at the end of the day the model in which we are interested so far. Only selection of the variable will not solve the purpose. At the end of the day, if I have selected my variable, I have to put those all variable in the model. Now what my model will say, whether this model, if apply this model, it reduces the biasness of the estimates. You see, for example, if I am saying how many COVID cases are there in India, that's fine. So for that, I use some theory and compute and give the estimates that this much amount of cases are there. If actually this much amount of cases are there, then my bias is 0. It might be possible that that model will not apply to America, that will not apply to Canada. It's okay, no problem. But my problem will solve. But it's a relative issue again.
So, Professor, sorry to interrupt you. So can we compare, like I have seen on television, people are comparing, look, what is the death rate in America and China and Italy, and look how death rates are. And they're comparing it. Is it meaningless?
No, they can compare. The for comparison, standardization is there. I can't say that it is not compare. It is comparable. That can be compared, but for that, don't use the crude method. Use standardized method. TFR is same for everywhere. Method is same. One thing is there, that physical structure, the behavior of the environmental effects, these are a different issue. But ultimately, the number of people dying among the number of population, that is same everywhere. But only if you use the crude measure for comparison, it is wrong. Use standardized method. You standardize both places on the same background and then compare. ये वही वाली बात है ना, गधे घोड़े को कंपेयर करने वाली बात है कि जब आप दोनों को अगर स्टैंडर्डाइज कर दोगे तब कंपेयर कर सकते हो. Yeah.
Thank you, Professor. Thank you, Professor Rajshri Dev. Very true, Gaurav. Acha, she's thanking you and she's missing your lecture, and she's telling that hearing it from the horse's mouth about the statistics, it's clear all the doubts and confusion in the life. Professor Dev, we wish you a bright future, and for your kind words. You really, I know that how intensive you are working. I salute your way of praising and your work. Thank you, Professor Dev. Thank you very much. So if there are no more questions, then I would like to formally thank Professor Rai for his insightful and wonderful session, which Professor has. Professor, I know that you are a bit busy there in the due to your administrative responsibilities, but in spite of that, you have taken time. Office of Doctoral Studies from the Office of from the JGU is thankful to you for your insightful session. We wish that we can invite you. We would invite you at the session personally, but because of this COVID, definitely once everything get over, we would love to see you here in the campus. I would love to invite you to address my PhD scholars, my doctoral students, that a full day seminar about statistics and roles and uses through your side. Thank you, Professor. Thank you very much for your insightful session. Thank you very much.
Thank you.
I would like to say thank you to all of my guests, professors, students, those who are here and attending the session. Thank you very much.
Thank you. Thank you.
So I would like to end the session. Before that, I'll request you all, if you can one by one leave the session, then I'll end the session at last. Oh, somebody is writing finally. On comparing COVID number is different countries. I remember Pandey sir's one quote, statistics is like donkey. It will carry whatever you put on it. Yeah, we should use statistics wisely, I'll tell you. It is like, I was reading in bachelor's first year. I still remember statistics is like a clay. So you can make devil or angel. It is in your hand. So misuse of statistics, and specifically for them, those who are aware, they can create blunders with the help of statistics, and that is not ethically right. So yes, you are in the industry, and I'm sure that you are going to contribute a lot through your insightful statistical conceptualization. Thank you, Gaurav. Thank you, Nisha. Thank you, Kirti. Thank you, Preeti. Thank you, Preeti Nair. Thank you, Rajeshri ma'am. Thank you, Sarni. Thank you, Prayas. A lot of people are there. Thank you, Deepa Didi. Thank you, Bangaraju ji. Thank you, Ravi ji. Thank you, Arnesh ji. Thank you, Pawan ji. Thank you, Kamran ji. Thank you, Rikshit. Thank you, Professor Sudarshan. Thank you, Sunil Gupta ji. Thank you, Shalika. Thank you, Priya. Thank you all for your time and your patience. Thank you very much. Thank you. Thank you, Professor Piyush. Thank you very much. I would
Okay,
like to
thank you.
now.
Thank you.
very
Thank
much.
you. Most welcome, Pandey. Thank you. Bye-bye. Bye-bye. Bye-bye.